Question number 5. A stone is falling at a constant velocity. What do you mean by constant velocity? Vertically down a tube. Which means what? The net force acting on the particle is 0. Okay. Which of the following statements about the energy changes of the stone during its motion are correct? Okay. The gain in kinetic energy is less than the loss in gravitational potential energy. What's happening over here? When a stone falls onto a tube over here, then what can happen when the stone is falling like this? There's a possibility that the potential energy is reducing because it's coming down over here. Kinetic energy should increase. But what is it, the kinetic energy increasing? No. Why? If the kinetic energy was increasing, then it will not fall at constant velocity, right? Here it's mentioned very clearly constant velocity, which means kinetic energy is not increasing. Kinetic energy is constant. So which means it is losing some kinetic energy over there, right? So the gain in kinetic energy is less than the loss in gravitational potential energy. So it is not, though the gravitational potential is reducing, it is not acting on to kinetic energy. Somewhere, some amount of energy is getting lost over here. So therefore, it is correct over here. This is correct. So this is correct. So some amount of energy has been lost. So this is true. The sum of kinetic plus gravitational potential energy of the stone is constant. When can this statement be true? When no energy is lost to the environment. But unfortunately, some amount of energy is lost due to the friction between the solid and the liquid. So therefore, this is incorrect. The work done by the force of gravity has the same magnitude as the work done by the friction. Obviously. Why? The force of gravity does something like this, which is your mg multiplied by s. This is the work done by the force of gravity. At the same time, there's some amount of work also being done in the opposite direction. So the net work done is equal to 0, though there is a displacement. Okay, you see, though there is a displacement and still the work done is equal to 0. What does it mean? If s is not 0, then f should be 0. Why is it f 0? The reason is because this f is nothing but f net. What is it now? F net is nothing but your f applied, which is due to gravity, minus the f friction over here, right? So dot s over here, so which we can say that the work done due to the gravity minus or plus work done due to the friction is equal to 0. That's what we are getting over here. In other words, work done should be equal to work done due to friction, right? So therefore, the answer C is also correct. Thus 1 and 3 are correct. 1 and 3, where is it? 1 and 3, B is the right answer.